Hello everyone. In this program, we are going to demonstrate the use of principal component analysis, which is PCA, on the iris dataset to reduce the complexity of the data and visualize it in the three-dimensional graph. PCA is a dimensionality reduction technique that converts multiple features into a smaller number of principal components while retaining most of the important information and variation in the dataset. In this program, the four features of the iris dataset are reduced to three principal components, making it possible to visualize the data in a 3D scatter plot and observe how different flower species are grouped based on their characteristics. So in this code, we firstly import the libraries. So first library is matplotlib.pyplot, which is used to create a graphs and visualization. Then we load the iris dataset by load iris. Then PCA is used for dimensionality reduction, and access 3D, it enables the 3D plotting. Then we load iris dataset by using iris is equal to load iris. And this X stores the features feature value of the flowers, and Y store the class labels of the flowers. Then we apply a PCA, which creates a PCA model with three principal components. Fit transform is learns the important patterns in the data and transform it into a 3D dimensional data set. XPCA contains the transformed data. Then we create a figure. Here we create a figure which sets the graph size into a 10 into 8 inches. Then we create a 3D plot inside a figure. Here we create a 3D plot inside the figure. Then we are going to plotting the data points, which plots the transformed data points in a 3D space. So XPCA here represents the principal component 1, and XPCA here this represents the principal component 2. This represents the principal component 3. C is equal to Y, which colors the points according to their class. C map Veritas is applies to a color map. S is equal to 50 sets the marker size. S is equal to 50, which is used to set the marker size. Then we label axis. Labels the X, Y, and Z axis with the component's name. Here, here we set the labels for the X, Y, and Z, and then we set the title, which is 3D PCA visualization of the iris dataset. Then we use the legend. We creates a legend showing the different flower classes represented by the colors. Then we show the graph by using plt.show function. Here is the output of the code. In this output, each point in the graph represents one flower sample. Different colors indicates a different flower species. The three axes represent the three principal components generated by PCA. Similar flowers appears close together, while the different flowers appears farther apart. The graph helps visualize patterns and class separation in the dataset after dimensionality reduction.